Hi all. Today we will discuss about Palo Alto networks VPN technologies. Basic concepts plus practical troubleshooting guide IPsec, SSL VPN and Global Protect. This is a day-to-day operations focused explanation, practical, structured and interview friendly topic. IPsec VPN, site-to-site VPN, basic concepts. IPsec VPN creates a secure tunnel between two networks over the internet, used for branch to headquarters connectivity, data center to cloud, B2B connection, back-to-back connections. It operates at layer 3 network layer. IPsec components in Palo Alto are IKE gateway that defines peer IP addresses, authentication, pre-shared key or certificate, IKE versions 1 and 2, encryptions, DH group lifetime. IPsec tunnel defines phase 2 crypto profile, tunnel interface, proxy IDs, interesting traffic. Tunnel interface, logical interface, example tunnel.1, assigned for virtual router, assigned to zone, security policy, must follow, source zone to the destination zone. IPsec phases, phase 1, IKE SA1, negotiates, secure channel, authenticates, peers, builds ISA KMP tunnel. Phase 2, IPsec SA, negotiates data encryption parameters, defines interesting traffic. IPsec technology troubleshooting methods step by step. Step 1, we need to check the tunnel status in GUI or CLI. In GUI, under network tab, we need to go to IPsec tunnels. In CLI, we need to give the command show VPN IKE SA or show VPN IPsec SA. Problem 1, IKE phase 1 not coming up. So these are the examples that which we face daily whenever the customer issue reported, that what needs to be checked in the Palo Alto firewall. IKE phase 1 not coming up. Common causes: wrong pre-shared key, crypto mismatch, peer IP incorrect, firewall blocking UDP 500/4500. So after that we need to check the logs, tailflow s mp -log IKE mgr.log. This is the log file name. Phase 2. So problem 2, phase 1 up, phase 2 is down. Most common cause: proxy ID mismatch, subnet mismatch, example mismatch, local and remote interesting traffic, subnets that we have configured, pre-configured might be different. Problem 3, tunnel up but no traffic. So we need to check the routing table, that is the command in CLI show routing table. Security policy, NAT rule, VPN traffic should not be NATed, proxy IDs. Daily IPsec checklist. So we need to follow the checklist whenever we are working on any tunnel issues which is configured in the Palo Alto. Whenever the customer raises a concerns which is not working, so we need to verify the tunnel uptime, check the replay drop counters, confirm routing, monitor the packet encapsulation and decapsulation. So SSL VPN, clientless VPN. The basic concepts: SSL VPN uses HTTPS 443 to allow secure remote access via browser. No IPsec is required. Commonly used for portal-based access, limited application access. How SSL VPN works in Palo Alto: configured through SSL/TLS service profile, authentication profile, LDAP, radius, SAML. Portal configuration, security policy, traffic encrypted using TLS. SSL VPN troubleshooting. Problem 1, portal not accessible. Check. Management profile allows HTTPS, certificate valid, security policy allowing 443, CLI. We need to test the SSL decrypt SSL handshake. Problem 2, authentication failure. Check. LDAP, bind credentials, authentication profiles, server profile reachability, In CLI, test authentication profile name, username, and the password. This is the syntax that we need to use to check the authentication failure issue. Problem 3, certificate warning. We need to check the certificate chain is completed. If it is expired, we need to renew the certificate in the client browser. Basic global protect SSL IP plus IPsec VPN client. Basic concept. Global protect is a Palo Alto remote access VPN solution. It interrupts SSL VPN, IPsec VPN, always on VPN, HIP, host information profile, checks used for secure remote access, device cache posture enforcement, zero trust access. Global Protect architecture, portal, authentication, agent configuration distribution, gateway, tunnel establishment, enforce policies, flow, client under portal, receives config, connects to the gateway. Global Protect tunnel models. So to configure the Global Protect tunnel, you have to go to SSL tunnel, TCP 443, IPsec, UDP 4501, automatically falls back to the SSL if IPsec is blocked. Global Protect troubleshooting. Issue 1, users cannot connect. Check. Authentication is working. License is valid. In CLI, we have to give the command show global protect gateway current user. Issue 2, checked but no access to the internal resources. Most common causes: missing route pushed to client, split tunnel misconfigured, security policy missing, DNS issue, and you need to check the routing. Comparative overview. Features: IPsec site-to-site, SSL VPN, and Global Protect. In future use case, branch connectivity, browser-based access, remote users in Global Protect. Tunnel type is IPsec, SSL/IPsec. Client required, no in IPsec site-to-site. SSL also is not required, yes in the Global Protect. User authentication is optional in IPsec. SSL VPN, yes. Global Protect is S. Device posture, no. SSL VPN limited. Global Protect HIP. Practical troubleshooting framework. Real world. When VPN fails, we need to check the below parameters. We need to check the tunnel status, IKE, IPsec, GP logs. Step 2, check the routing, route exists. Step 3, check security policies, correct zones. Step 4, check NAT, VPN traffic NATed. Step 5, we need to check the logs, systems logs, IKE logs, Global Protect logs. Most common root causes in productions. Symptoms. Root cause: tunnel down, PSK mismatch, phase 2 down, proxy ID mismatch, connected but no traffic, missing route, GP connected, no internet, split tunnel issue, frequent disconnect, ISP packet loss, iCPU, DPD retrace. Final takeaway: for Palo Alto troubleshooting, always think the connectivity, negotiation, routing, policy, NAT, logs. That orders solves 90% of the VPN issues in the real environments. The real world VPN outage case studies. So we are talking about another session that is for the VPN outage case studies in the real world. Palo Alto Networks, real world VPN outage case studies, practical scenarios seen in enterprise environments, site-to-site, IPsec, and Global Protect. Each case includes symptoms, root cause, troubleshooting path, final fix, and lesson learned. Case study 1, IPsec tunnel flapping every 30 minutes. Symptoms: site-to-site tunnel drops exactly every 30 minutes. Applications freeze briefly. Phase 1 and phase 2 reestablishes automatically. Root cause: IKE lifetime mismatch. Firewall A, 8 hours. Firewall B, 30 minutes. When one side rekeys, the other doesn't respond properly, tunnel resets. Troubleshooting path. Check SA lifetime, show VPN IK SA, show VPN IPsec SA in CLI on the firewall. Compare both the peers, IK lifetime, IPsec lifetime, key margin, review logs, less MP log, IK mgr.log, found repeated rekey negotiation failures. Lesson. Always validate lifetime encryptions, DH group authentications on both peers during deployment. Case study 2. Tunnel up but no traffic passing. Symptoms. IPsec tunnel shows green up. No ping between subnets. No traffic counters incrementing. Root cause. Asymmetric routing. Return traffic used a different ISP instead of VPN. Troubleshooting path. Verify the tunnel counters. Show VPN IPsec SA. Ncaps increasing. Decaps 0. Check routing table, show routing route found, static route pointing to the internet instead of tunnel interface. Final fix, corrected the static route to the tunnel interface. Lesson, tunnel up, traffic flowing, always verify, routing, proxy IDs, counters. Case 33, global protect connected but no internal access. Symptoms, user shows connected, cannot access internal servers, internet not working. Root cause, a split tunnel misconfiguration. Only one subnet was pushed to client. Troubleshooting path. Check the client routes, route print, compare with the internal network list, verify the gateway configuration. Split tunnel includes list incomplete, added missing internal subnets. To split tunnel includes first. Lesson, always validate split tunnel config, root push, DNS push. Case studies. Phase 2 fails after peer upgrade. Symptoms. Phase 1 establishes, phase 2 fails, worked before peer firewall upgrade. Root cause. Peer device changed the proxy ID from 10.0.0.0.8 to 10.1.0.0.16. Mismatch caused phase 2 failure. Troubleshooting path. Show VPN IPsec SA, no SA created, check less MP log IK mgr.log, proxy ID mismatch or error found. Final fix. Matched proxy IDs exactly on both the sides. Lesson, proxy ID must match 100%, even small subnets, differences breaks phase 2. Case study 5, global protect disconnecting randomly. Symptoms, users disconnect every few minutes, especially home users, reconnects automatically. Root cause, ISP blocking or rate limiting UDP 4501 IPsec mode, client falling back between IPsec and SSL repeatedly. Troubleshooting path, check the GP logs, less mp-log pan underscore GP event log. Observed, IPsec negotiation timeout SSL fallback. Final fix, forced SSL only mode in gateway settings. Lesson, remote users behind CGNAT/ISP filtering often break IPsec. SSL is more stable for remote workforce. Case study 6, VPN outage after policy cleanup. Symptoms, all branch tunnels drops, IK negotiation fails, worked before policy change. Root cause, security rule rumored, security rule removed following UDP 500, UDP 4500 ESP between peers. Troubleshooting path, check the traffic logs, no IKE traffic seen. Packet capture shows dropped UDP 500. Final fix, re-added the security rule allowing IKE/IPsec traffic. Lesson, never forget, VPN negotiation itself needs policy allowance. Case study 7, iCPU on firewall causing VPN drops. Symptoms, Multiple VPN tunnels unstable, high data plane CPU, users complying of slowness, root cause, DOS attack causing session exhaustion, VPN packets dropped due to resource limits, troubleshooting path, show running resource monitor. Found session table near max, high packet buffer usage. Final fix enabled zone protection, increased session limits, mitigated attack source. Lesson VPN issues sometimes are symptoms of resource exhaustion. Case study 5. Authentication failure after AD password change. Symptoms all global product users failing authentication, portal data reachable. Root cause service account passwords expired for LDAP bind. Troubleshooting path test that authentication profile. Bind failed. Final fix updated LDAP service account password. Senior engineering troubleshooting pattern. When VPN outage occurs, the senior engineer follows the below steps to investigate the VPN issue. Step 1 is the tunnel negotiated, IKE/GP status. Step 2 is the traffic encapsulated, encapsulation/decapsulation counters. Step 3 is routing correct, static/dynamic routes. Step 4 is policy correct, zones and services. Step 5 is NAT interfering. Step 6 are resources exhausted. More frequent production root causes top 10. Proxy ID mismatch, PSK mismatch, missing route, NAT rule, interfering, split tunnel misconfig, ISP blocking UDP 4501, expired certificate, expired LDAP password, policy cleanup mistakes, session table exhaustion. Final takeaway. In real world environments, 60% of the VPN issues are reporting to routing or proxy mismatch, 25% policy/NAT errors, 10% authentication, 5% crypto mismatch. VPN troubleshooting is systematic, not guesswork. So today's session is I explained about the VPN technologies and the examples that we need to follow and the case studies which clearly explain that what are the steps that we need to follow whenever the issues occurs with respect to the VPN, global protect. So and also lesson learned. So whenever we're working on any issues, we need to note down the lesson learned, what we learn on the particular issue for the next troubleshooting that if we get same issue reoccurred for some other customers. Thank you.